To factor something means to write it as a product. For example, to factor the number 15, we would write 3 times 5. In this lesson, we will be factoring trinomials that have a leading coefficient of 1. Before we do any factoring problems, I would like for us to review the steps involved when we multiply 2 binomials together. From this process, we can draw some conclusions that will help us when we start to do factoring. Let's take a look at those examples now. You probably remember having learned to use the word FOIL to multiply 2 binomials. We'll use that here. F, for the first terms, multiply x times x, we have x squared. The outside terms are 3 and x. When we multiply those together, we have a positive 3x. The inside terms, positive 7 and x, give us a product of positive 7x. And then the last terms, 7 times 3, gives us a positive 21. Adding our 2 like terms here in the middle together, we have a product of x squared plus 10x plus 21. The first thing that I want you to notice, we multiplied 2 binomial factors together, and our solution was a trinomial with 3 terms. So most of the time when we factor a trinomial, we expect to see 2 binomial factors similar to this as our solution. Now let's look also at this product. This x squared is the result of multiplying our first terms. So that is like the F in FOIL. Our last term over here is the result of multiplying our 2 last terms together. So this positive 21 is like the L in FOIL. But notice that 10x is the result of adding together our outside product and our inside product. So this middle term is actually outside plus inside. If we will remember that when we start factoring, we can start with the first term knowing that the factors of this first term should be the first terms in our factors up here, and factors of the third term should be the numbers that appear as our last terms in our 2 binomial factors here. Then we have to just make sure that our outside product plus our inside product gives us this middle term. Now I want to do these other examples to talk about what happens with our signs when we do this process. X times x gives us x squared. Our outside product here is a negative 3x. The inside product is negative 7x. And here, multiplying our last terms, notice we have a negative times a negative, so we get a positive 21 here. Adding our like terms in the middle, we have x squared minus 10x plus 21. Comparing these 2 examples, let's notice that first of all, if our third term is positive, since that third term is the result of multiplying our last terms in our binomials together, if we have the same signs, either both positive or both negative, then this third term here is positive. So we can reverse that when we start to factor and know that if our third term is positive, we will have like signs in our 2 binomial factors. Also notice that because adding 2 positives gives you a positive and adding 2 negatives gives you a negative, this middle term right here will tell you when you have like signs whether those like signs are both positive or both negative. So we'll want to remember that when we factor. Now on our third example, x times x is x squared. Our outside product is negative 3x. The inside product is positive 7x. Our last terms gives us a negative 21. Adding our middle terms, we have x squared plus 4x minus 21. Notice that our third term here is negative because we have opposite signs in our two factors. So this will be another thing we'll look for. If our third term is negative in our trinomial, we know we must have opposite signs in our factors. Now, this middle term, when you have opposite signs, will sometimes be positive and sometimes be negative. Remember, it will depend on which of these numbers here has the largest absolute value. So when we have a negative third term, although we know we have opposite signs, we're going to have to use our middle term to determine where those opposite signs would go. When you do factoring, it is really a trial and error process. Sometimes I call it guess and check, because what we do is guess the factors, multiply them using FOIL, and see if that is the problem that we were given to factor. Now, let's remember the things that we saw in these examples. I've written them down. Let's take a look at the things that we want to look at as we examine a factoring problem. First of all, always look for a greatest common factor. If there is one, factor it out first. I cannot stress to you how important it is to develop this habit of looking for a greatest common factor. There are two reasons for that. The first reason is that when you are asked to factor, that means to factor completely. If you do not get your common factor factored out, then you will have an incorrect solution. The second reason, though, for doing that first is that if you have a common factor and can get that factored out, the other numbers in the problem become smaller, and it's much easier to find the factors of those smaller numbers. The second thing we want to remember, as we said, if the third term is positive, the factors will have like signs. The signs will be the same as the sign of the middle term. And then third, if the third term is negative, the factors will have opposite signs. The sign of the middle term will determine where those signs go. Now, we're going to use these things that we've seen here to work some problems. Our first problem is x squared plus 5x plus 6. I notice that, first of all, there is not a common factor for these three terms. So I'll examine the signs in the problem. I notice that this third term here is positive, so I know I will have like signs. Since my middle term is also positive, I know that both of my factors will have plus signs. Now, we will start our factoring looking at the first term here. To get x squared, we know we would multiply x times x. So in our two parentheses that we're going to use for our binomial factors, for our first terms, we want to write x times x for this first product of x squared. Since we already know we have like signs and they are both positive, let's put those in. Now, remember that the numbers that go here must be factors of the third term. There are two possible types of factors for 6. We have 1 times 6, and then we have 2 times 3. So we must either use a 1 and a 6 or a 2 and a 3 in these positions. Now remember, the outside product plus the inside product, since they're both plus signs, will add up to 5x. So that helps us by looking at these possibilities over here to assume that we would probably use the factors 2 and 3 since those add up to 5. We will put those factors in and then check our solution. X times x is x squared. Notice our outside product here is a positive 3x. Our inside product is a positive 2x. If we add those together, we do have our middle term of positive 5x, and positive 2 times positive 3 gives us positive 6. So we do have the correct factors here. Now I would remind you that had you written x plus 3 times x plus 2, this would still be a correct solution. Remember that multiplication is a commutative operation. That means the order that factors are written down in does not affect the product. So these are the same two factors that we have written here. They're simply written in a different order. And if you check your multiplication here, you will see that it will give you x squared plus 5x plus 6. Our second example is x squared minus 7x plus 12. Again, I notice there are no common factors here. Looking at our signs, we have a positive third term indicating that we will have like signs. This time, however, both signs will be negative since our middle term is negative. So let's make some parentheses for our two binomial factors and start with the first term. To get x squared, we would multiply x times x. We know we have same signs, both negative, so we'll put those in. Now, for these last two numbers, we must use factors of 12. Possible choices would be 12 times 1, 2 times 6, or 3 times 4. So we must use one of these pairs of numbers in our last positions. Since our middle term is a negative 7x, and we have like terms here, our inside and outside product will be added together for negative 7x. Since 3 and 4 add up to 7, we will try those numbers. Let me put those in and let's check our product. X times x is x squared. Our outside product is negative 4x. The inside product is negative 3x. That adds up to our middle term of negative 7x. And negative 3 times negative 4 does give us that positive 12. So we do have the correct factors here. X squared plus x minus 6. Again, there is not a common factor here. Notice this time our third term is negative. This tells me that I will have opposite signs in my factors. Our first term, again, must be the product of x times x, so we'll put those letters in. Since our signs are going to be opposite, I do not want to write the signs in just yet because I'm going to need to be careful about where those signs go to give me this middle term here. The numbers that we use in these last positions must be factors of 6. Our choices again are 6 times 1 or 2 times 3. Now, as we think about doing our outside and inside product, if these have opposite signs, these products will have opposite signs. When you add two terms that have opposite signs, you actually find their difference. So we're looking for two numbers whose difference will give us a 1. That would indicate using the 2 and the 3. Let's put those in. Now, I have an outside product of 3x here and an inside product of 2x. If these have opposite signs and I want to have a plus 1, the 3 must be positive and the 2 must be negative. So following that around, if this outside product is going to be positive 3x, I need the plus sign in this factor. And if the inside product must be negative 2x, I need the negative in that factor. So we have x minus 2 times x plus 3. Remember, if I write x plus 3 first and x minus 2 second, I would still have a correct factorization because these are the same factors, but just in a different order. The thing that would be different here is that my outside product would be negative 2x, my inside product would be positive 3x, but these still give me a positive 1x for that middle term. X squared minus 6x minus 27. Again, there is not a common factor here. Since my third term is negative, I will have opposite signs again. My first term will each be x. X times x gives me that x squared. Now, this time we need factors of 27. That could be 27 times 1 or 3 times 9. Since we have opposite signs, we need numbers whose difference is 6. Since the difference of 3 and 9 is 6, I'm going to try a 3 here and a 9 here. My outside product is 9x. My inside product is 3x. If these have opposite signs and I want to get a negative 6x, I need to have a negative with the 9x and a positive with the 3x. That means my outside product will be negative 9x, and the negative sign goes with this factor. My inside product needs to be positive 3x, so the plus sign would go with that factor. My outside product is negative 9x plus 3x for the inside product gives me negative 6x for my middle term. And positive 3 times negative 9 gives me my negative 27 for that last term. X squared plus 2x plus 8. There is not a common factor in this problem. This tells me I will have like signs, both positive. My first terms will both be x's. Since I know that I have like signs, I'm going to put those plus signs in. We need to use factors of 8 here. That could be 1 times 8 or 2 times 4. Remember, the outside product plus the inside product needs to be a 2x. Neither of these add up to 2. Let me show you what happens when I try these. If I try the 1 and the 8, my outside product is a positive 8x. The inside is a positive 1x. That adds up to a positive 9x, which is not my middle term. So this would not be the correct factors. If I try using the 2 and the 4, let's put those in and see what happens. My outside product is a positive 4x. The inside is a positive 2x. When I add those together, I have a positive 6x, which is still not my 2x. This also is an incorrect solution. Now, is there any need for us to try any other possibility? The answer is no. There must be like signs, both positive. We have tried that. There's no reason to try negative signs or opposite signs here. These are the only factors of our third term of 8, and those factors did not work. So we cannot factor this problem. You might recall that not everything can be factored. When we cannot factor, we often use the word prime to indicate that. So I'm going to write prime here for this trinomial. And that would be a correct response for you to write if you have a trinomial that will not factor. Now I'm going to put some problems here that I would like for you to try. You need to pause your tape and copy these problems down. When you have finished working these problems, then you may restart your tape. We will come back then and show you how to work these problems, and you can check your answers. So pause your tape and then come back. Let's take a look and see how you did on these problems now. Your first problem was x squared plus 11x plus 24. You should have noticed that there was not a common factor. You have same signs, both positive. So starting your factors for your first term, you would multiply x times x. You can go ahead and put in both of your plus signs here. Then you need factors of 24 to go in these positions here. Your choices are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Since you have same signs and both are positive, you will be adding your outside and inside product to get your 11x. So that would suggest using the factors 3 and 8. Let's try those and check our answer. Our outside product is a positive 8x. The inside product is a positive 3x, which does add up to our 11x for the middle term. And 3 times 8 is positive 24. So you should have written either the factors x plus 3 times x plus 8, or in the other order, those same factors, x plus 8 times x plus 3. In your second problem, again, there was not a common factor. You have same signs, both negative this time. Using x times x for your first term, x squared, and since we have two negative signs, we'll put those in. Then we will try factors of 20 in these positions. 20 can be written as 20 times 1, 2 times 10, or 4 times 5. Since our signs are both negatives, we will be adding two negatives to get 9x up here. Since 5 and 4 add to 9, let's try those numbers here and check. Our outside product is negative 5x. The inside is negative 4x, which does add up to negative 9x. And negative 4 times negative 5 is positive 20. So the factors are x minus 4 and x minus 5. X squared plus 5x minus 24 does not have a common factor. Since your third term is negative here, you will have opposite signs in these factors. Your first terms, again, are x times x. Our outside and inside product here will have opposite signs, so we will be finding a difference to come up with our 5x. We need to use factors of 24 for these positions. 1 times 24, 2 times 12, 3 times 8, and 4 times 6 are our choices. Since we'll be doing a difference this time, 8 and 3 seem to be the likely choices here. Let's put those numbers in and see what happens. My outside product is 3x. The inside is 8x. With opposite signs, I need positive 8 minus 3 to be the positive 5x up there. So my outside product needs to have a negative 3x, putting the negative in this factor, and that leaves the plus sign for this one. We have our middle term, and positive 8 times negative 3 is our negative 24. X squared minus 5x minus 15. Again, we see that we will have opposite signs in this particular problem, and there is not a common factor. My first terms will be x times x. I need the outside and inside product combined to be negative 5x, and I need to use factors of 15 in this problem. That could be 1 times 15, or it could be 3 times 5. Those would be our only choices. Since I will be having opposite signs and I need a difference of 5, it would seem with these numbers that that would be impossible. Let's check just to make sure. If we try the 1 and the 15, having an outside product of 15x and an inside product of 1x, with opposite signs here, I would either have a positive or a negative 14x, which is not negative 5x. Switching positions would not make any difference in terms of what these outside and inside products combined would give us. So this will not work. Let's try the other numbers here of 3 and 5. Here the outside product is 5x, the inside product is 3x. With opposite signs, I would either have a positive or a negative 2x. Again, this is not giving me that middle term of negative 5x. So this combination also does not work. Since we have to have opposite signs and these factors don't work and those are our only choices, this particular trinomial is prime. It would not factor. Now, I'm going to show you some examples that do have common factors. We mentioned earlier how important it is to look for those, but we wanted to practice some problems before we got into having a common factor. Notice that the numbers 3, 15, and 42 are all divisible by 3. So we can factor out 3. Remember, factoring out 3 is like dividing each term by 3. We get 1x squared here. If we divide 3 into 15x, we get a positive 5x. And dividing 3 into negative 42, we get a negative 14. You can always check yourself at this point by distributing your common factor and seeing if that gives you your original problem. So we know at this point that we do have the correct factors here. But we're going to look at this trinomial here to see if we can factor further. Now, you want to be sure that you do not lose this common factor. So what we're going to do is just recopy that common factor here, and we will make our open parentheses to see if we can factor this problem. For this first term, we have to have x times x. Since our third term here is negative, we're going to have opposite signs in this problem. So this outside and inside product here would have opposite signs also. Factors of 14, our choices are 1 times 14 and 2 times 7. With opposite signs to get 5x, that would suggest using 2 and 7. Let's put those numbers in and see. Our outside product is 7x. The inside product is 2x. With opposite signs, a positive on the 7 and a negative on the 2, I would get positive 5x. So my outside product needs to be positive 7x, the inside negative 2x, and notice that our third term is negative 14. This time, to have this problem factor completely required 3 factors. We have written 3 times x minus 2 times x plus 7. We have mentioned that the order factors are in does not make a difference. I could write 3 times x plus 7 times x minus 2 and also be correct. There is one convention that we do kind of stick with, and that is if we have a common monomial factor, that means just one term, we generally always write that particular factor in front. That way it does not require parentheses around it. So normally we'll always put our 3 in front, but these 2 factors could be in any order. Now this problem is a little different from some that we've seen because notice our first term has a negative sign. We have not factored any that had a negative first term. What we're going to do to make this problem look more like what we have done in the past is we can treat this negative 1 coefficient of x squared as a common factor for all of these terms. So we're going to factor out negative 1. Now I'm going to write negative 1 like this just for emphasis. I'll show you in a minute that generally we do not put the 1, it's understood, we only put the negative sign. But I want to emphasize here what we're doing. If I divide this term by negative 1, I get a positive x squared. If I divide this by negative 1, I have a negative 8x. And if I divide this by negative 1, I get a positive 12. Now check yourself. If you distribute your negative 1, you do have the original problem as it was written. Now, as before, we don't want to lose this negative 1 factor. As I bring that down, I'll write it like I said we would do earlier and just put a negative sign there. We will make open parentheses to try to factor this trinomial that's written here. This is understood to be negative 1. For our first term, we will have x times x. Since our third term is positive, we have like signs. Since the middle term is negative, we know that both of these signs will be negative signs. Our outside and inside product needs to add up to negative 8x. We will be using factors of 12. Our choices are 1 times 12, 2 times 6, and 3 times 4. With like signs, we need to add to 8. That suggests using the 2 and the 6. Let's try that. Our outside product here is negative 6x. The inside is negative 2x, which does add up to our negative 8x in the middle. And we have negative 2 times negative 6 is positive 12. So our factors then are negative 1 times x minus 2 times x minus 6. Let's look at this problem. Looking at the three terms, I do not see a common factor in this problem. Now, one thing that's different that we've not seen before this example is that we have two letters involved. Notice that we have x squared here, we have a y squared in this term, and our middle term contains both of those letters. You'll see as we do the factoring that this does not create much of a problem for us. We're going to do the same steps that we've done before. Since there's not a common factor, we will start by looking at our first term. That needs to be x times x for our x squared. Since our third term is positive, we will have like signs, both positive due to that middle term. So let's put those signs in. Our outside and inside product needs to add to 8xy, and we need factors of 7y squared for these positions. To get 7y squared, we might multiply 1y times 7y. Is there any other way we could get that? Well, there's really not, because the only factors of 7 are 1 and 7. So let's try those factors here and see if we have a correct solution. Notice that my outside product is a positive 7xy. The inside product is a positive 1xy. If I add those, I do get the positive 8xy in the middle, and my last terms multiplied together is the positive 7y squared. Two x to the fourth y squared minus 8x cubed y minus 42x squared. Now you should notice that we do have a common factor here. Looking at the numbers first, all of these numbers can be divided by 2. So we have a common factor numerically of 2. But notice your letters. We have an x in every one of these terms. When we factor out variables, remember we can factor out the variable with the smallest exponent. So between x to the fourth, x cubed, and x squared, the 2 is my smallest exponent. So we can factor out x squared. Now notice that we have y's in these two terms, but there is not a y here, so we cannot factor out any y variables. Let's take this common factor of 2x squared out. Dividing 2x squared into 2x squared y to the fourth, we have x squared. You can check this multiplication. We have x squared y squared. Checking this multiplication, we have 2x to the fourth y squared. Then dividing 2x squared into our middle term, we get a negative 4x to the first power, y to the first power. Checking that, we have a negative 8x cubed y. And then our last term, we get a negative 21, and that's all. 2x squared times negative 21 is negative 42x squared. So we're certain we have the correct factors here. Now let's bring down our common factor of 2x squared, and we will attempt to multiply this trinomial here in the center. Now for this first term, since I have both x squared and y squared, we need to multiply xy times xy to get our x squared y squared. Notice that we will have opposite signs in this problem. So as we do the outside and inside product here, With opposite signs, we'll be finding a difference of 4. We need to use factors of 21 in these positions. 21 times 1 and 3 times 7 would be our choices. Since we will be finding a difference of 4, I think we will probably use the 3 and the 7. Let's try that. My outside product is 7xy. The inside is 3xy. With opposite signs, to get a negative 4, I need a negative on the 7 and a positive on the 3. That means my outside product needs to be negative, the inside product positive. And notice I do have my negative 21. So the complete factorization here is 2x squared, notice the monomial factor, times the factor xy plus 3 times the factor xy minus 7. Now, just as we did earlier, I have a couple of problems here that I would like for you to try. If you will pause your tape and work these two, then when you come back, we'll see how you did on these problems. Let's take a look to see if you have correct answers. For 2x squared plus 14x minus 36, you should have noticed that you have a common factor of 2. So your first step would be factor out the 2. That would give you x squared plus 7x minus 18 for your second factor here. Now, let's bring down the common factor of 2. To get x squared, we would multiply x times x. Notice that since your third term is negative, this outside and inside product will have opposite signs. And we're wanting to get a 7x from that combination. We will be using factors of 18. Our choices are 1 times 18, 2 times 9, and 3 times 6. Since we will be finding a difference, and we want 7, let's try the 2 and the 9. The outside product is 9x. The inside product is 2x. With opposite signs, and to get plus 7, we need positive 9 and negative 2. That would place a positive sign in the factor x plus 9 and a negative sign in the factor x minus 2. You could write 2 times x minus 2 times x plus 9, or you could write 2 times x plus 9 times x minus 2. In this last problem, since your first term had a negative, we're going to want to factor out that negative as a negative 1. But notice that's not the only common factor here. If you look at each of these terms, you'll notice that the variable y appears in all 3 terms. The smallest exponent that y has is the first power. So we can also factor out y. So our common factor will be minus y. Dividing this term by negative y, we will get a positive x squared. Notice if we multiply these, we have negative x squared y. Dividing your middle term by negative y gives us a negative 13xy. Again, checking here, we have a positive 13xy squared. In our last term, we will get a positive 36y squared. Checking this, we have negative 36y cubed. So we know we have the correct solution at this point. Bring down your common factor of negative y. For your first term, you would multiply x times x. Notice we have same signs, both negative. Let's put those in. Our outside and inside product added together should be 13xy. We need to use factors of 36y squared. Our choices are 1y times 36y, 2y times 18y, 3y times 12y, 4y times 9y, and 6y times 6y. We had a lot of choices for this last problem here. Since we have same signs, we need some that will add together to be 13. So let's look through this group. These two added together, would be 15. I was looking at the wrong one here. These two added together would give me 13xy. So let's try 4y and 9y, and let's see what happens. We have a negative 9xy for our outside product, a negative 4xy for the inside product. Adding these, we get negative 13xy, and a negative times a negative here gives us our positive 36y squared. So the correct factors would be negative y, x minus 4y, and x minus 9y. This completes our lesson on factoring trinomials with a leading coefficient of 1. In another tape, we will look at factoring trinomials that have a more difficult leading coefficient. We will do basically the same steps, but it becomes a little bit harder because we have more choices to look at. I hope that you will take the time to check that out if you need additional help with factoring. We would appreciate very much if you would rewind this tape when you have finished before you turn it in so that it will be ready for the next student. Thank you very much.